So today I wanted to talk to you a bit about building cross-platform super apps with React, React Native, and Repack. So I guess before we start, I really have like three questions to ask you, so we get better idea um, where should I pay more attention to while I go through this. So first of all, I wanted to ask how many of you are working with React on a daily basis? Okay, and I if that is expected. Okay, so I'm guessing the second question was about React Native. Anybody works with React Native that doesn't work with React? Okay. And then in this case, how many of you have a native mobile app that is a super app or a mobile app with native features? Something like Richa. Yeah. Okay, so not many, which is maybe good, maybe bad. I hope the presentation will not be too abstract, but I hope it will inspire you to think about it from potentially different perspectives than you were thinking. The presentation is going to be more of a technical walkthrough through how to build those features with React, React Native. So there will be some React-specific features. I'll make appropriate annotation as we get there. So before we start, I want to introduce myself. This is me a few months ago. I'm pretty much changing every season. So next time you see me, it will be totally different. So I'm CTO and founder of CodeStack. We are core contributors to React Native. We've been working with React Native since the beginning with beta. I've been one of the first contributors to the framework for almost 10 years now. So if you're interested in React Native's history, I'm happy to answer your questions and I'm happy to walk you through some of the good or some of the bad decisions we made down the road. Here's one of the first POs I've made to the repo. I don't even know what we were fixing back then, but yeah, it's almost 10 years. It's crazy how the flies. So today I really want to talk to you about micro frontends, which is really the technical term that sits under the super applications. And more specifically, how you can build super apps or module micro frontends with module federation, and in this case, Repack. The topic originally was about super apps, but micro frontends are growing. Micro frontends are really available widely on the web thanks to great adoption in Webpack, which is sort of one of the most popular bundles on the web. So I felt like that title was a bit more appropriate. So what are the things that I will walk you through today? Well, first of all, I will give you a bit more context behind Repack and React Native, and maybe we spend a bit more time here to better understand it since some of you haven't worked with React Native yet. And then I want to show you what is Repack and how you can build super apps with it, show you an interesting concept where you can leverage React Native JavaScript to build a mobile application that is a platform at the same time, which means you can expose SDK third-party developers and invite people outside of your secure realm to contribute to your mobile platform. And then benefits and things that we didn't cover today. So let's go. Traditionally, mobile apps had limited options for dynamic content, right? If you wanted to display something dynamic in your mobile app, you either had to use a web view with HTML inside, think, Instagram FAQ section or something like that. Or you could do something that is oftentimes called a JSON-driven UI, which typically means a backend sends a JSON that describes what should be there in the UI, and then you have some parsing logic on the client to turn that into whatever is the framework that you use. And then, that feature on the right side, when you send a JSON from the backend to the client, often was connected with a feature called bundle splitting, which really meant that since your UI was changing over time, you didn't really want to include all the components, all the features inside your JavaScript, but rather you wanted to maybe offload them for later so that when the client visits your application or web application, it will load quickly. And then only when you start sending those additional JSON elements, you will be downloading additional chunks. So that is what was called a bundle splitting. And on the web, we solved it quite elegantly in case of a typical application. And I'm sorry, because apparently the purple color is not really readable here, but we have typically a single application file, the bundle, which is the result of bundling of your front end. And then we can split it into multiple chunks, and then we end up with 3 chunks to a vendor and maybe some feature chunks. And back then, many years ago, that was very revolutionary because we could split it and maybe cache independently hosted on the CDN, which was pretty much and revolutionary back then. And then there was this concept of module federation that was what bundle splitting evolved to throughout the Webpack community, which means that instead of splitting your application into a single chunk, you could now create the chunks independently. So really, the difference here, I hope this is readable, is that rather than splitting a single application into multiple chunks, you develop multiple applications separately, and you connect them into the final application layer. So the key difference here is that you can do that independently, right? So you can imagine having 5 different teams, building 5 different applications, filling the end result, sending it to an entirely different team or a product team, and that team will compose the final product. They don't have to sort of share the build pipeline because they can use module federation for that. And as you can see, this is the timeline of that development from bundle splitting through module federation on Webpack. And up until recently, module federation has been turned into a bundle agnostic standard. So it's not just a Webpack feature anymore. It is now a feature of other bundlers such as ServicePack. And Vive community is working on their own support in rollup as well. So we can expect that coming soon. And so the question here, which is pretty obvious to React Native developers, but I'll spend some time explaining here, is can we bring it to React Native? React Native historically, React Native is pretty much JavaScript that runs on your device and talks with native so that when you write HTML-like looking React components, it will result in native looking UI. Historically, the Facebook team didn't use any of the available bundlers on the web. So they didn't use Webpack. They didn't use, what was there back then, Galway or something to verify. They didn't use any of these, but they created their own called Metro. And Metro was highly optimized for use cases that Meta had internally. But as a result of that, it didn't really support the features that community supported. So for a very long time, it didn't have bundle splitting. It didn't have module federation. It didn't have any of that. And so it is a very valid question to ask, can we really bring it to React Native? At the end of the day, it's a web application, and React Native is nothing but a JavaScript runtime. And obviously, I'm here standing to say that the answer is yes. And to do so, there is a couple of tools. And the first one I will be showing you today is called Repack, which is an alternative to Metro for React Native. So you can think of it as, if you want to use Webpack in React Native, this is the tool that you will be using very early as soon as you start your project. So going quickly through the reasons behind this, first of all, it's always good to have a choice. And, React Native defaulting to a one and only Metro bundler was not a good situation in a way that it could not benefit from alternative solutions. But then, secondly, we just see a huge value of sharing your infrastructure across platforms. When you think about building React and React Native, the huge promise people have is that one component will run across multiple platforms. And while this is cool, there is also a build pipeline below this, and being able to share the build pipeline, in this case using Webpack on both web and mobile, really saves a lot of time. And then obviously we have module federation that we just talked about. A little sneak peek here in this video is that just recently we started working on bringing module federation support to Metro as well, together with our partner Zephyr Cloud that I'll show you later. So the takeaway from those slides is that no matter what you do, 3 months from now, you will be able to use module federation of React Native. And I'll show you on a picture and video what that really means and why this is cool. So that said, we have all the things we need in place to start building. We have support, we have good DX, performance, and HMR, which means host module replacement. So we have everything to start building cross-platform microfrontends. So that was slightly technical part that was very specific to React Native, but now we can start going into more general system design, I believe. So here is an overview of a federated application. Now I will quickly jump to this video and to this picture, and then I'll go back. Let's take an Uber, for example. So typically, when we are dealing with a federated super application, it means that we're going to be dealing with multiple features. And as you can see on the top right, reserve or those food, grocery, convenience, health, these are many times totally separate code bases or applications. This could be an insurance provided by an insurance company. This could be payments provided by a bank from a local country. And this could be changing per geography. Have you ever noticed that whenever you go with Uber, this UI always changes depending on what's supported? It's the same app. And this is how they can manage, like, this is what sits under the hood of that experience. So if your application looks like anything like that, chances are high that you're already sitting on that architecture. So going back to this architectural diagram, what it means, like I told you before, is that each feature is developed separately. So the application 1 is done by the team A, the application 2 is done by team B, and the application 3 is done by team C. They're totally separate frontends that can be deployed wherever you want. But then there is also another team. In this case, in the case of Uber, that would be the main Uber team that would be putting those features into it and compiling the final product. So if we look at this diagram, if we all in this room work for Uber, we would be working on different icons here, and maybe then 5 people from this room would be responsible for putting up the whole container into place. And that way we could be developing really fast. And in this talk today, I really want to show you how to achieve that with React and React Native. And I really want to present you a concept, very simple tips and tricks. How can you structure your application using those tools to make this available, make it scalable, and make it fast? So first of all, let's have a look what's inside each federated module. Now, since you told me you haven't worked with React, the feature that people love React or hate it for is the presence of JSX, which basically means you can write HTML-like syntax inside JavaScript. And this is just nothing but a JSON. So when you transpile this code based pure JS, those HTML-like tags are converted into a tree. This is just a way to describe a nested tree. So what we can see here is that we have a Spec Navigator container and some other components inside. What this really is in practice is the way in React Native to say, I have a container, a view controller that can present two view controllers on top of itself. So in this case, the eats navigator. So in this case, that would be the, I believe the left one, the green one, would have a list of restaurants and restaurant details, right? So you could see all the restaurants, and then when you press it, we would navigate the details. So we have two screens. And here on the right, we have the rights, where we have location picker, the right options, something like that. So the key is that we expose the screens we have available, and then each federated module is standalone. So you can run it separately from the main application, but you can also pull it into the primary application. Here, I believe it will be much easier if I show you the quick picture. Here's a animated GIF that actually shows what happens. So here on the left side, like this is a free showcase we have on the GitHub. It's open source. You can check it out. On the left side, you have the final product, a application with multiple modules. So here we have upcoming appointments. This is booking submodule. And then we have products, which is the e-commerce submodule. And here, the middle, as you can see, is the actual interaction that happens inside the application. So when users download your application from the App Store, when they tap any of these, they go directly straight to the submodule, with, in this case, the booking module. On the right side, you can see the booking module is running standalone. So the team that is working outside from the main application can just run it as a standalone portion. So the modules are standalone, but at the same time, they are also being able to be integrated into the main application. So it's more like a nice way to share the state of the navigation. And then this is a bit of JavaScript here. You may be thinking, how does it work in practice? Module federation is very simple. It's async import. So a federated module is an NPM package, and module federation lets you import it asynchronously. So if you're using any bundler on the web, typically when you do an async import, that's a code splitting path. So a separate bundle chunk will be created. And here, module federation lets you import that automatically. The lazy wrapper comes from React. When you wrap something with lazy, it becomes a component. In this case, its navigator is a lazy import of a X component. And then we wrap it in suspense. Suspense is also a React component. If you wrap something that is async with suspense, it will show a nice fallback, in this case, a stinner, and then when it loads, it will swap with the UI. So it's a bit of React magic to declaratively load async stuff. That's what it is. The key takeaway is that it's a very smooth and easy integration. And then finally, final step really depends on your setup. Like I showed you before, pretty much the screens are React navigation screens. React navigation is, again, a React native library that you can use to sort of say that there is a screen with the name Uber Eats, points to a given component, and it has certain options such as title, animation, lookup. So it's really a declarative way to display it. There's a couple of other things to do. You can check out the README of the project itself. There's like a lot of options. Here on the left side, I graded out of it, is a webpack config originally needed to set it all up to work with React Native. And on the right side is what we created to make it a bit easier for you to process and understand. But really, the clue here is support for third-party developers. So many times when people are dealing with architectures like the one from Uber Eats, the question that I see most of the times is, first of all, is it possible with React Native when they migrate from native? But then the second is, how can we provide a stable environment for third-party external developers so they can, I don't know, if we are Uber, we don't want to invite them to the whole code base, but maybe if there was a small shell they can run outside of our team, that would be pretty cool. So let's keep that Uber analogy going forward. This is the traditional integration. So this is how traditionally it is being done. Here on the right side, you have your mobile UI, and whatever is there, some part will be a third-party module. In this case, let's say this is ride-sharing provided by Uber. So don't make me not ride-sharing. Something else not provided by Uber, but somebody external, I don't know, maybe travel insurance. Right, and then on the left side, what happens is third-party provider will tell us this. Hey, listen, we are insurance broker. Here's our API. Let's go do it, implement it. And it will be on your side to do the error handling, state management, UI integration, everything. And many insurance is simple, but there might be something more complex. If your app grows to many different modules, this might be really complex to deal with without having that external knowledge. We can turn the table around with the media app structure, because if our shell, in this case, this skeleton on the right side, can run and execute a code provided by external developers, all we have to do is we can give an SDK by saying, this is our mobile app, this is our skeleton, these are the APIs you can expect, these are the permissions that we provide, implement your code and send it back. It's obviously never that simple, but I'll show you a couple other ways to do so. So this is obviously possible, which is good news. So I just want to show you how SDK can be done. Again, this is React-specific feature, so this slide will probably be slightly tricky to process at the first sight, but I'll try to break it down. In React, you have context, which means you can pass an information from top of your tree to the bottom of your tree. So think about having a user profile component somewhere deep your hierarchy, and maybe at the very top, you have user data provider, which is the component that is responsible for getting DKA your user. So in this case, what we can do is we can provide data from the host. So host is wrapping each media application of those providers, saying, this is the user context, this is the payments information, these are the methods you can call. And then we have federated module that is using those use SDK hooks. These are custom hooks, but doesn't really matter. What it means is the federated module can rely on a dynamic information provided in the runtime. So we can think about it as a very elegant React native way to do dependency injection. So in practice, what it means is that in React, first of all, we will create context. So we will tell it, this is the context that the default values are typically just throwing in errors. This is just for your ease later. Pretty much, if you forget to wrap your code in provider, you want to get an error, right? So that's why you typically just do this throw new error. And this use payments hook is just a React way to make it look more fancy. And then we have the context provider. So in this case, we have an SDK runtime provider. And as you can see, we are using payments provider. And payments provider expects a object with ethos such as charge. It's obviously very simple for this purpose, but I'm just showing you an idea. So we are providing the payments. As you can see, the SDK runtime provider is wrapping the federated module. So it's wrapping the third-party code. And then we have the suspense, because the third-party code is downloaded dynamically. So the federated module code is not actually bundled with our application. We just ship it without. And federated module can be downloaded dynamically once the application has been installed based on geography, based on user profile. Good example is you're a car manufacturer and user is logging in with their VIN number, and the car turns out to have a heating seats and maybe remote control. You want to download those modules in, tied to this car, and maybe do not download something else because it's not legal to be used. So a very, very simple structure. And so then to use the SDK from the federated module, we just use the payments. And so if this is being run outside of the provider, this will throw an error, so it's pretty convenient. The benefits are, first of all, fine-grained control. You can leverage this mechanism to, for example, request Apple style-like permissions. So the production SDK implementation on the left side, user object in this case, it will await to check permissions, and it's in this case it will just ask the user to grant permission to return user object, and the developer of the media app does not have access to it. So whatever is provided as user implementation doesn't really concern me as a media app developer. In testing environment, this will not check for permission, obviously. It will be a hello world John Doe. But then when I send you the code, you will swap the SDK runtime provider with your production provider, with your own infra, and then this code will behave more real-time. It's kind of like a difference between simulator and real device. So in this case, we will stop here, check for permissions, and granted missing. And the point is that this is up to you to implement it, so it's not prescriptive. I'm just showing you the general approach, but obviously the choices you make here will highly depend on your application. In this case, you can see, like I said about the sandbox, the sandbox itself can return just John Doe and a success true, whether for testing or, I don't know, imagine I like using the car as an example because many years ago I was at a hackathon in BMW Munich, and they were building applications for their infotainment. And I was speaking with the team and I was asking them, how do you test it? And they told me they had an actual car in the basement and they wait 25 minutes to see whether their application compiles. And I'm like, guys, this is crazy. Like, this cannot work. Maybe the reason why I hated some of the features they were working on as a customer as well. So this may seem like an obvious thing, but it's really not in many cases. And if they had a system like that where they could block the car behavior in tests and send it outside of the headquarters, that would be really useful, because the problem for them was, first of all, we cannot give you our hardware, it's proprietary, and then we cannot even send you the car. So even harder, right? And then the interesting aspect here is the cross-platform UI, which I think is, based on what I see speaking with developers of different meetups, really getting interesting and popular. So just like we inject through SDK an object such as user, payments, whatnot, we can also provide UI elements. And here on the bottom, you cannot see it, but it says web, iOS, and Android. So what I'm saying here is that instead of using view text and button from typically React package or React Native package, you can use those components from the SDK you create yourself. So if you want to provide UI kit to your external developers or internal developers, you can do it. And what is the benefit of this? You have no idea where this code is going to run, but it's going to run and it's going to deliver the value. In this case, there is not much value, but it's going to work. So the idea here is that we abstracted some of the critical things so that if you're building, let's say an application for the payment system, you don't really care whether this is iDrive 7, 8, 9, or 10. It's just supposed to work, and you could have some more high-order components too, like menu bar, that to cover that use case. There is obviously a few use cases that I didn't tell you about, and these things typically require manual effort. The first one is the CI/CD, ideally one that works with federated modules. What people often love to have, but it's not available, unfortunately, is an App Store-like infrastructure. So say, okay, I can invite external developers. What I need now is a infra where they can upload the code they created. I can drag and drop it. I can review it. I can push it to production. I can roll it back. All sorts of different things that typically Apple would do or Google would do from the management back perspective. There is a third-party provider called Zephyr Cloud that does just that. I know for many enterprise customers, they cannot really outsource such a critical piece of infrastructure. But if you are a startup, or if that is not concerned for your case, I highly recommend Zephyr Cloud IO. Here on the left side, you can see, for some reason, we all like personal color, which is not looking good here, but it is a breakdown. It's a tree of your application. See, the mobile host is the mobile application router. And then we can see automatically that they have a sub-module for orders. They have sub-module for inventory. Inventory has a home screen, the product details screen, and they also have a mobile cart that is a whole separate module. And then they also have a checkout at the bottom. So they split the whole application into chunks. The benefit of that is, let's say, they can have 5 different ordering experience, maybe 5 different white label access codes. Like I said, the developer portal is missing, so there's a bit of manual work. Which raises questions that, like this: how do we accept those external modules? Do we use GitHub? Maybe some sort of hosted solution with UI? And again, the answer is it depends. And I want to show you the real life example. There is a company called Moho from Vietnam. You may recognize it. This is the diagram in their development portal of everything that happens when they submit media for their region. They have manual process, and they sort of show it pretty much at the beginning. You just develop media, you build it, and you send it for the review. You can see everything that happens here is the steps they do on the back. Then we have security. JavaScript famously is running on a single thread in a single context. So we have, I have seen examples of a healthcare company using this architecture, and they were concerned about maybe data leaking from sensor devices when third-party code is behaving in an unexpected way. Typically, everything is going to run in a short context. So when you do something crazy that you typically don't want, but maybe you overlook it, like you change the prototype, which is like, I think, the classical JavaScript thingy from like 10 years ago, at least before classes. This will return a wrong result. So you want to explore things like, obviously, doing a security audits, which is obvious, but many times we can overlook things. But also a sandbox, which is also supported in the packages. So each app can run in a separate engine instance. So you will have an entirely separate JS execution context. And if something bad happens, it would be happening with a single media. Or you can just use it internally without external developers. And in this case, nobody has this issue unless you do it intentionally, which can also happen. So I think with that in mind, I wanted to say that, first of all, you should really check out federated modules because, those architectures are really cool. Not just for, I would say, building those platforms and super apps with third-party devs, but just generally for making you more productive on the front end. If you're building any front-end application and you have multiple teams, everybody wants to ship faster, everybody wants to move faster, I guess. I hope, I wish you that. And in this case, the federated modules will enable this by unblocking teams from depending on each one another. Obviously, there's time for questions, and small QR code if you want. Actually, it's quite big. If you want to scan it, I know that this might be quite, I would say, new or very, very low-level thingy, but this architecture can be added in a week to any application you have. So if you're like, sounds cool, but I want to try it, or maybe you want some guidance, like I'm happy to help. We're doing this for our clients. We're doing this for just simple consultations. So if you just want to hang out and talk about open source, I'm happy to help you with that as well. Because at the end of the day, if you use federated modules, that tool becomes even more popular, which is good for the community.